So, like it says on the screen, my name is Tom Tierney. I farm in Kildare, just south of Dublin, for anyone that doesn't know where Kildare is. It's mainly a tillage farm with some forestry. The tillage farm is a conservation agriculture farm. So, the slideshow I'm going to show you is a journey into conservation agriculture. So, as we go through the slides, I did it in a kind of pie chart that I kept building on, so you can look at the pie chart and see the next step, if you like. So I've done it in steps, so hopefully it explains itself as we go. However, the topic of the discussion that I have to bring into my slideshow is the role of soil biology in plant nutrition. So I probably should say a few words about that before we get on with the slideshow and explain my farming journey. Soil biology and plant nutrition, what's the importance of it? I suppose for the last 50 years we've used synthetic fertilizers, and the more we used, the more we got, is what we were told. And we used synthetic fertilizers because it was the right thing to do, and it paid us to do it. And we didn't question it. So you put the fertilizer on, you got the yield, basically. I don't think we even understood then, definitely, how the fertilizer got to the plant. And I suppose that's the biggest thing I learned on this journey, is that the fertilizer just doesn't get spread on the ground and washed down to the roots and get taken up by the plant. It's soil biology that gets it there. So at its core, that's the importance of soil biology. So, and you'll see it as we go through the slides, the importance of soil biology in the nutrients that it makes available. So soil biology will mine nutrients from the soil, whether it's synthetic or whether it's organic form. And in doing that, it will then feed the plants. And there's that symbiosis between plant root life and soil biology, and the soil, which is the home of soil biology. So, conservation agriculture, what is it? Well, conservation agriculture isn't regen agriculture in my mind. I'm not a regen. I don't call myself a regen farmer. And the reason I don't call myself a regen farmer is because when you look at the principles of regenerative agriculture, I won't go through them, you can read them, but number 5, integrate livestock. I don't have livestock on my farm. My livestock are my soil biology and my worms, if you like. But in a true regenerative farm, you would have livestock that you would cycle through your farm fields and cycle back into cereals, and so it's a complete living system. I don't have that. I don't see myself having that. I did have a suckler herd at one point in the 90s, but beef wasn't the same price then as it is now, so they went. And I was on my farm. I was a conventional farmer until 2016. And then an opportunity presented itself, and I went no-till farming. So one of the messages I'd say is never let an unexpected opportunity pass you by if you see one. And that's exactly what happened. I ended up with a no-till drill, and then I had to learn how I was going to use the no-till drill. And so in a way, I did it in a kind of reverse to the way I asked people. If they're talking to me about direct drills, I'll say to them, there are 3 things you need to do first before you look at a direct drill. And these are some of them here. So you need to have living soil all year round. So living soil all year round means that you would have a winter cover crop if you were growing a spring crop. In terms of a cereal farm, some of you guys mightn't be cereal farmers, but I could have a field that would be for spring cereals. So instead of having it bare stubble, I'll try and have a cover crop, and the cover crop will provide food and nutrients to the soil biology. And the more diverse the cover crop is, the more diversity you bring to your soils. Crop rotation, everyone has a crop rotation, whether you're conventional or regen or conservation. Crop rotation is the most important step. I suppose when you look at it, crop rotation is a diversity in itself. It's over a 5 or a 7 year plan that you might have. And then number 3 on the list is adding organic matter and compost. So when I started out first, I wasn't really looking at compost. I was looking at organic manures, and I was probably looking at organic manures from the nutrient value or the potential nutrient value, NPK fertilizer values. And I realized as I moved along over the years, number one, you have to put out a lot of farmyard manure to get the bang. And I also learned that if you can make a compost, you can end up with a product that you can use at a reduced rate, maybe 1 to 3 tons the acre, instead of 10 tons, let's say. And in doing that, you were leaving it easier for yourself with workloads, but also you were bringing a living compost rather than a farmyard manure that was anaerobic to your field, and therefore it was more biology available, if you want to call it that. So, step 2, when we look at it, the very first thing I did when I went no-till drilling, after I did the first 3 steps with crop rotation, which I was doing anyway, cover crops and adding compost, the very first thing I did was eliminate insecticides. And it was kind of like, I would call it a breakthrough moment, if you like. When I was looking at my no-till stubble that had living plants in it in November and December, you could see there was a lot of insect activity within the landscape that the plant was growing in. And they were insects that I was probably going to kill if I put out an insecticide. So I went a bit cold turkey and decided not to put on insecticides anymore. And also at the same time, in making that decision, insecticides were losing their efficiency. So they weren't actually preventing the virus from getting into a crop because the aphids had built resistance and the virus had built resistance. So you kind of step back and question, why am I spending this money on an insecticide that doesn't work? So it was a really easy decision in the end not to use an insecticide. And since 16, I haven't used insecticides, and I haven't been wiped out with barrier divorcifiers, which is the main reason for using an insecticide in the first place. So, yeah, and there is a lot of predator life, and in the stubble, in the living soil landscape, we'll call it. And I had farmers beside me who were conventional, and they would see barrier divorcifiers, and I wouldn't have any. And I don't know the reasons, but there's lots, I'm sure. But I think one of the biggest reasons is that the stubble from the previous crop was masking the greenness of the crop that I was growing in that current year. So the aphids see rich green fields, and I want to land and feed on the crop. But if they couldn't see the greenness because I had it masked with stubble that was higher than the crop that was growing at the time, they flew on and hit the neighbours, and I kind of escaped that one. So I felt like I had a gain there. So yeah, insecticide was the first thing to go. I could see the predators increasing, but I could also see worm numbers increasing. Now, the worm numbers that were presenting themselves then, because I had switched to no-till, were vertical burrowing worms. So what they do is they live in a burrow that they dig vertically into the ground, come up at night, reach out. Most of their body will be in the burrow, but they'll reach out and draw in debris that they'll eat as food, stubble debris, chopped straw. And they'll make a little wigwam over their burrow so that they're safe and sound and free from predation. And I never saw these guys when I was ploughing. They just didn't exist because the plough inverts them, and they don't have their burrow. They can live in the burrow for years at a time, but if you invert the burrow and do away with that worm, you've depleted that worm number. So I saw a huge reversal of that when I went no-till. You could see that worm numbers were increasing, and if you walked out at night with a flash lamp, all of those middens made with the little wigwams made with the straw debris were alive, and you could see the guys, and as the light would shine on them, they'd retract and go back into their burrow. So there's no good reason not to be no-tilling, and there's no good reason to be ploughing, and I don't see anyone in Ireland with a field that can't be direct drilled. That's on the direct drilling side of it. The next step, so there's the worm middens I was talking about, and they would be littered all around you. So you would expect, in my soils now, I would see maybe 20 of these over the winter within a square metre, all over the field. And it's all down to not ploughing, mostly. So step 3, reducing synthetic dependence. That was the next thing I looked at. So if you see here, we're looking at nitrogen reduction, and we're looking at fungicide reduction. Basically, they're the synthetic ingredients that we're talking about. So in reducing nitrogen, there's something else that you need to look at, and that is foliar feeding. So you need to hone in on your leaf analysis. You need to get a leaf analysis done and see what sort of deficiencies are present, trace element deficiencies like calcium, magnesium, boron, and so on. And a big one for me, I use it a lot in every application in the field, regardless of what's in the tank, will be silica. So silica is a natural product, but what it does is it strengthens the plant cell walls, and it prevents. In a way, it prevents. It keeps the plant healthy, and it will help it fight off disease attack or insect attack, perhaps as well. But it's a bit like a human taking multivitamins, really. But the other elements also have a significant role: boron, magnesium, calcium, and so on. So doing a leaf analysis will tell you what you need to apply to your crop to make it grow so that you can reduce the fungicide dependence and the nitrogen dependence. And I suppose the nitrogen dependence, why is that so important? Well, growing cereals conventionally, you could be using 200 units of N to grow a crop of wheat. I'm not there anymore. I don't use that. So there's a significant saving to be made as well. So nitrogen dependence needs a look at. So how do you do it? So there was a lot of talk about melting urea and applying urea as a foliar feed. So I examined that and I got into it. And around about 2018, 2019, I think it was, around about the time of COVID, and a lot of us guys in base were talking about starting to melt urea and applying it as a foliar. So you apply it with your standard nozzle on a standard crop sprayer, and it can be applied on grass as well with the same effects as a cereal crop. But cereals in general are a bit more intense in their management and agronomy that you need to apply. So what sort of reductions have I seen? So I'm now applying 128 units to the acre. Instead of 180. I was never on 200 anyway. I couldn't see the benefit of going that high, but I'm back to 128 units an acre, or 18 kilograms of N per hectare if you want it in the other format. So it's a significant, it's at least 1 bag of nitrogen in simple sense. And across the whole farm, it's probably somewhere close to 10 tons of fertilizer that I don't buy anymore, okay? So that's the N, and I can come back to it in a bit. The other side of the equation was the synthetic fungicide use. So in a way, with the foliar nutrition you're applying, synthetic fungicides are reversing your attempts with your foliar application. So I tried to reduce fungicides where I could too. A typical crop program, spray program would be 3 fungicides, which I seldom do anymore. It's at least, it may be 1 fungicide. I try and replace calcium, magnesium, boron with the fungicide instead of using the fungicide, and silica, and seaweed, and molasses. There's a whole, it's a real rabbit hole you can go down. The thing about all these steps is it didn't happen overnight. So I kind of took a slow approach to it, and weigh up the benefits. So like if I step back to insecticides, I didn't just see it overnight happen in the following year that I have a whole heap of worm numbers here. It was a gradual process. So like I said, I'm doing this 10 years, and these few steps that I've just talked about took maybe 6 of them to get to where I am now. So it's worth remembering. The last thing I did was the fungicide reduction, and it's still ongoing. Some years I might use 2 fungicides, other years I'll use 1, and some crops I'll use none. Some crops I'll use 1 more than the other crop. It varies all the time, but in general sense, it's a reduction. So foliar feeding. Yeah, so here we have the first slide, the first IBC. IBCs are valuable if you can get your hands on them. The first one is a seaweed mix. So I was buying seaweed in a can off a supplier, but this year I sourced seaweed from Ballyhonus in its raw form, dried and ground. And I'm trialing it. I don't know how it'll go through the sprayer. We'll find out. The other thing in the center there is, well, the seaweed. Why would I want to use seaweed that's I want a seaweed that's in its most natural state possible. So in other words, straight from the sea, dried and ground, rather than something that's processed and in a can. The middle one then is BAM, so that's biologically active microbes. You can use them anywhere. You can breed them. I buy them. That's the small 10 litre in the background. So you add that 10 litre to molasses water and put a bubbler on it, seal it, put a bubbler on it, and you can use it wherever you need it. You can apply it to soil, you can apply it to plant, these are simple things you just can't go wrong with. And the last one there is humates. So humates is another natural product. It's brown coal, if you want the definition of it. So humates come from the soil as well, but they're loaded with biology and biology food. So I buy the humates and I breed it up to or mix it up in a IBC and apply that. Really good to use on the plant at any point. The thing about all these guys here is that they're low cost. The molasses is low cost. If you're using low cost molasses at a litre to the hectare, it's costing you about 20 cents. Why wouldn't you try it and why wouldn't you do it? And when molasses was the first thing I looked at, followed by silica. And if you're looking at a cost of 20 cents an acre usage, why wouldn't you try it and see does it give any benefit or any adverse effects? If there's no adverse effects and it's costing 20 cents, why not persist with it and see can you add something else to it? So I add seaweed. So seaweed, molasses and silica are my go-to mix. And I'll start with that as a seed dressing. So it goes on the seed in the slot behind as I drill, and I kind of view it as a signature feed. So it's telling the seed what's coming. It's also giving it a bit of nutrition and getting it out of the ground and giving it a kick. Does it work? I've no science behind me that tells me it works, but I've no science behind me telling me it doesn't work either, so why wouldn't I do it? That's the approach. Trace elements, that's just showing you the trace elements in the bigger picture. The other picture is how I melt urea. So the bag is suspended off the teleporter over an IBC, and I just use a sludge pump to circulate. So for anyone that wants the details, how do you, here you go. So you get an IBC, it's how I do it. People do it differently. I put in 600 litres of water and I'll add 1 bag to that. And as the bag melts, it will fill the IBC to 1,000 litres. So that 1,000 litres, then I'll use it across 50 acres, along with more water in the sprayer, which will give me 6.57 units per acre as a foliar feed. The thing about that is, I reckon it's worth 14 units in real terms. So, as if it was soil applied, in other words. So, what I'll do is I'll use 100 units of N on the growing crop in March to get it started. It'll be a soil applied N, granular or foliar. And then I'll apply 4 applications of 6.5 units. That gives me my 128 units per acre. So that's how I do it. I'd love to reduce that number more on the soil applied N, but time and time getting it across the acres is the issue. It takes a lot of work. I'd be living in the sprayer. I can do 4 comfortably, so I'm happy enough there. It's shown a significant saving. Why melt urea and not use bag urea or foliar urea, soil applied urea, or soil applied N for that matter? So when you oversupply N to the soil, you burn off biology. And when you burn off biology, it's just like ploughing the field. When you plough the field, you burn off biology. So it's exposed to oxygen, and off it goes. And you'll hear people saying, oh, if you disturb the soil, you get soil mineralization. You do. That's biology burning off, and nutrients left behind that the crop will take up. So in the same reason, I don't want to oversupply N. So in not oversupplying N, I'm preventing leaching, and I'm preventing soil biology dieback or population decline. So how do you know when your soil is active? Well, organic matter is the benchmark I use. So the higher my organic matter, the more biology I have. But organic matter is what I put on the field. And when I put that on the field, it's converted into humus by biology, which is the plant food. So I had to do a bit of digging. When I was a conventional farmer in plough-till system, I had very little. Organic matter didn't matter to me, really, I suppose, is the short way of putting it. And it was very hard to find an organic matter test I had ever done when I was in that frame of mind. But I did find one field, and it was the lowest field in organic matter, because I was trying to find out what was wrong with the field. And it was 3.5. In 18 and 19, the Department of Ag brought out soil testing, and it was kind of mandatory. So I said, well, when we were doing mandatory soil testing, we'll test for organic matter as well. So I have organic matter across every field on the farm that I farm. And the guy was doing it the first time he was out. He was soil testing, and he had them all done. I met him at the car, and he's ready to go home. And I said, did you do the forestry? And he said, no. So I said, well, you'll have to do the forestry. I want NP or P and K, PHP and K, and organic matter in the forestry as well. And the results are there. It was clay-based soil, the same as the farmed land, and it was 18%, right? Versus my farmed fields at the time, which were 3, 4, 5%. So how come a forestry that was planted in year 2000 had 18% organic matter, indexes P and K on 3s and 4s, and a pH that was bang on the button, 6.5, when it had got no management and no lime and no bag fertilizer, synthetic or otherwise? So it lends itself, you have to question these things. So I know I can't achieve 18% organic matter in my crop fields, but it's a target. And yeah, in 2025, my average soil organic matters across all crop fields was 7.5. So we're heading in the right direction. The highest field in 2025 was 11.6. We're heading in the right direction. I don't know where I can go with it, but I feel the more organic matter I have, the more biology I have. And that's what the talk is about. It's about soil biology and plant nutrition. So organic matter is the key to that. to that process, in my view. Achieving healthy functioning soil. So it's kind of the end slide, really. So by looking at the inner circles and seeing how and what we've done, you have your healthy functioning soil, building organic matter, improving carbon capture, which I never even dwelled on, but anyway. So pesticide usage, this is a snapshot in 2022. Tagus, the advisory in the south, wanted to do a survey on my farm versus a standard conventional farm, and these are the results that they got from that in 2022. So significant less pesticide usage, which is good. It's less money out the gate, and I'm all about less money out the gate. And that's me. If you're looking to find out more about conservation ag, I'm there, you can contact me. What I didn't mention is the drill that I started with in 16. It's a New Zealand build drill, and I'm an ambassador for that company now in Ireland and the UK, and I promote, where I can, conservation ag with the drill. And that's my journey so far. Thank you. I think we're doing questions at the end. And I think Ali is up next. I'll introduce him. He's a big man from Limavady.
Morning, everybody. Thanks very much for making the effort to come and see us. As Tom says, I'm Ali Craig, big man from Limavady. I spent the last 2 days at my cousin's wedding, so I am not in great shape today, unfortunately, but here, I maybe should have thought about that before I signed up. So where's the clicker? Oh, sorry. Which one is this one? Green on the next, yep. We're mixed arable and dairy. Just put up a wee bit of background information about what we do. The screens aren't that big, so hopefully you can see it. We're farming about 650 acres in Limavady. Pedigree Holstein herd. We're probably going to try and reduce slightly. We have too much stock. A couple of years of bad TB, unfortunately. And then down at the bottom, we started doing the calf-free TDF heifer rear in 2019. Became the HDB monitor farm. It's finished this year, but did it for 3 years. Joined BASE in 2023, BASE Ireland, and I joined Burrowing in December past there. So our journey has been relatively short so far. I'm really only into farming more environmentally friendly the last 3 or 4 years. So probably actually after I joined the monitor farm program, got me asking a lot of questions, joined another couple of groups that you probably ask more questions after joining them, but it's been a busy couple of years. This is just a soil sample I put up of a typical field, typical ground in Carse Hall. We farm below sea level, so it's a bit different. We have been using manures, slurry, that sort of stuff for the last 25 or 30 years, so we have built organic matters up, probably not too bad. We were ploughing in one pass and they're ploughing and drilling before, so now we've went to a more of a direct drill. You can see that our organic matters have actually raised by an average of 1% over the whole place in 3 years, which I find that as a win. Shows them trying to do something right. Our P and Ks are slightly down, but they're still at the same indexes. But if you go into the milligrams per litre or milligrams per kilo, they are coming down slightly, which is probably also a win. And our pH is starting to come down to a level, like our pH 3 years ago was 7.8 to 8.2, and now it's starting to come down a bit to a level where grass and green actually likes it a bit more, sort of in around the 7 or slightly below. quick slide about our dairy enterprise. So as I was saying, we have 270 cows. Quite different that we have 165 on cubicles and the rest is on straw bedding. Obviously we have straw. It's probably not called a waste product anymore, the value of it, but we have plenty of straw there. We use the straw, then we use the manure to grow the crops again. So we try to keep it a bit circular. Just a bit of information, what we do. Our multi-cut silage is, we try to take 6 cuts a year, starting in April and finish in October, along with maize at the end. So, yeah, once a month to try and increase our protein, so we're not buying in as much protein. It's hard this couple of years for protein from America is dirt cheap. So it makes you wonder, but I think we're still doing the right thing. We're still growing. We're focusing more on home saved fodder basically to try and the cows are our money maker. Nothing else really leaves, so apart from the milk. So yeah, we're trying to be a bit more environmentally friendly with the cows. We're actually pushed the last couple of years to go A2 milk. I'm not too sure if it makes a big difference or not, but I just think going forward there might be a market that we can sort of click into there and get us a wee bit more income maybe. And this is our arable enterprise. So about 250 or 300 acres a year of arable. The last 3 years I've seen massive changes to the arable. It's completely different to what we used to do. So this year we did we haven't used P&K for a long time, but we have 0 fungicides and 0 growth regulators on this year, which has been interesting. I think you have to have a bit more patience whenever you're relying on nature to do its thing instead of just firing it on. So yeah, 3 or 4 years ago we used to grow winter barley and that was it. Just one crop. We're in now to 5 or 6 crops. A lot of them are companion cropping and are intercropping, cover cropping. So we've it's been a busy few years. Learning all this stuff. So, little slide on what we do for organics. I would love to do what Tom's chatting about and do composting, but with the volume of manure I have, it just takes up a lot of ground. So I haven't got into that yet. So we're applying slurry with a double bar, and we have a 6-meter injector if it gets too dry or too hard, that the slurry will dry up on top. We try to use the tram lines in the field, so we're 36-meter tram lines, and we'll try and control traffic on 12-meter with a double bar with the use of a hose humper. And then our dung, the BAM applied, again Tom spoke about BAM, we use it to 2, we sort of brew our own up. We put 1 litre on top of every bale before it's sprayed, and that helps the breakdown of the manure. So we're not composting, but we're finding that it helps speed up the process of breaking the dung down, both in the midden and in the field. And if it takes up less room in the midden, it's a great job. So this sort of tells a bit of a story about where we were and where we're going. It's our fertilizer, comparing our fertilizer use. In 2012, we would have went through 7 or 8 loads of fertilizer in a year. Try and push growth. And looking back, fertilizer was cheap. It's handy, fertilizer spinner. You know, you just went on every month, and you fired on whatever you thought you needed. Now it's a wee bit different. We've probably halved our fertilizer use in the last 3 years. Well, in the last 12 years, but especially in the last 3 years was the start of foliar feeding. We moved to Omex fertilizer, which is a liquid fertilizer, 5 or 6 years ago. And seen good benefit from using that instead of granular. So this is just the next step to go to foliar and try to melt our own granular to put it on better, basically. So whenever we're using our Omex, we're putting up 30 to 50 units on our arable ground. The ground at home is probably getting 30, and the ground far away is getting 50 because it's not as cheap to cart slurry to the ground far away. We were putting on 30 units per cut of silage. What we liked about it was the lorry comes in, fills the tank and leaves. I have a 5,000 litre sprayer. You can cover a lot of ground and no telehandler, no anybody else running after you. Just me out in the field, which is nice. Then we look at our foliar, what we're doing. we're topping up our arable. So the likes of our wheat crop got some of them got 2 doses, some of them got 3 doses of foliar this year. So like I'm talking, barley got 35 units total inorganic fertilizer. Obviously got a top up end of the organic. But our wheat got 55 units with the top ups of the foliar. We're putting at the minute this year, we've put 10 units every cut of silage, so we're seeing a huge saving there. And it's easier to mix. So we're mixing it with fulvic, acid, molasses, Epsom salts, whatever. You can mix, well, as long as it doesn't curdle in the tank. We've done that twice this year, so again, learning curves, but you have to do it. But as I said in the bottom point, it is cheaper, but it takes time, and time is money, I suppose. So I've put up my foliar recipe there for anybody that wants it. We use urea, sulfate of ammonia, fulvic acid, molasses, and I use a lorry, an ex-bitumen tanker, that I have a mixing point front and rear, and I mix it with a dodo pump. I put it on about 150 litres a hectare with a sprayer, and that equates to about 10 units. And then the recipe to the right hand side of that is if you're doing a cube. Not everybody has a tanker sitting about. And as I say, we add in a lot of trace elements, a lot of seaweed, Epsom salts. It's cheap and cheerful and gives the plant something. As I've touched on earlier, we've changed our establishment method from what it used to be to what it is now. We bought a direct drill that we have a subsoiler in the front of it. So I don't think you could call it a direct drill anymore. It's maybe a strip till drill. I don't know. It does the job. It means now I do most of the field work, so it's 3 passes instead of 5 or 6 passes before. So it gives me a bit more time. We've focused a lot on companion and intercrops. So most of our crops, other than wheat and barley, will be sown with 2 or 3 other families to try and get this. I thought those 2 photos were great actually, because it just shows all the roots intertwining, like they're obviously working together instead of against each other. And we seem to be getting good yields. We seem to be getting a good response from the plants themselves. I haven't done any leaf sampling as such. Probably just a bit laziness of me getting around the fields doing everything, but you can see it, when you walk into the field, you can see it. The plants are healthier, they're doing well. We're putting in a lot of spring beans as companions, and spring beans is fantastic for breaking up compaction. So if you can get plants to do it for all the price of the seed, fire it down the drill. If you can get plants to do it for you, brilliant. This is our seed dressing that we started using. We looked at this, actually there was a growing meeting down at ours probably a couple of months ago, and I just sowed a field of oats with peas and beans. And somebody commented that as they call them rasta roots basically, so it's like dreadlocks in the roots, and that's a sure sign of having a biological seed dressing. So I'll mention protozoa T later on for those who don't know what it is, but it's just a very simple mix, 10 litres a ton. I've borrowed a pan mixer from a friend of mine, so I'll try and use a pan mixer to see if it's going to work any better for me, make it a bit easier. So this is what we started more on this year, is brewing up our own nutrients. As Tom has alluded to, brewing's super cheap. It's not always easy, but it's cheap and cheerful, and if you have a pile of cubes lying about, it's not hard to put an airlock on them. And try to brew something useful for very little money. So we've brewed lactobacillus, lab, BAM, seaweed. We bought seaweed straight from the water. Actually, we didn't buy dry. We went to Dunlow and Donegal and lifted 2 ton along with 40 boxes of fish guts and heads. I sent somebody for that. Funny enough, I wasn't for getting my hands dirty. But no, we have 4 cubes now. Again, we were buying seaweed in, and seaweed's expensive to buy in a cube. You're chatting $2,000, $3,000, and I thought if I can brew up 4 or 5 cubes for, I think it was €500 for the seaweed. If I can brew up 4 or 5 cubes, get them tested, see what they're like, and maybe that could be a thing going forward. you'll have seen in some of the past photos, we have a sea wall which has seaweed. I wanted to buy it first to make sure it was the right stuff. Everybody raves about Joe Gallagher and Dunlow, so I bought his stuff, try it out, see what it does, and maybe the next time do a cube of my own and test them against it. And Protozoa tea, we're probably in a lucky position. We have 30 acres of lucerne, which isn't grew much over here. So Protozoa tea is basically, it's lucerne full of protozoa. You brew it up aerobically, so you have a bubbler in, put a bit of molasses in, rainwater, let it bubble for 48 hours, and it actually smells like herbal tea. I didn't taste it now, but it smelled really, really nice. And we put that on. It's fantastic worm food. So if you put it on your ground or put it on your seed treatment or whatever, the worms are meant to love it. So for anybody that doesn't know what LAB is, lactobacillus acid, this is the steps that we used to make it. It did seem to work quite well. So we were using our own milk. We actually bought in rice, but you can use just a seed wash. You're basically just getting the outer of the seed, to start the process. And I have the steps up, but the Jerry Gillespie, if you look up Jerry Gillespie bioferments on Google, it'll take you straight to the website. He has 5 or 6 different recipes where you can do biofertilizers, and it's a very good website to go and have a look at. This is our BAM. We started with 20 litres. We're now up to about 8,000 litres. You brew it up. So the first one is we buy a 20 litre drum in. That's what you add to a cube, basically. Put the wee bubbler in. Then once that 200 litre drum is filled, and it's all BAM. So BAM works out about 3.5 pH, but you can smell it. You just know the smell of it. Once it's ready to go, we'll put that into a cube, and then you brew up a cube. And once you have a cube filled, then you can split it in 4 or 5. So it's just, again, it's a wee bit of time, but it works, and I find a benefit to using it. Again, Graham Sate he's the main man at NTS, and he actually does a YouTube series about how it's done. I find it very useful too, so just fired that out for anybody who's interested in it. So a bit about what my future plans would be. As I say, we try to reduce our reliance on soya. So growing high protein crops for milk cows is probably suiting us. Again, increase soil health. That should be everybody's future plans. I tried a wormery last year, and again, probably time, but I didn't look at it too much. Didn't really do well. So maybe during the winter I'll try and get back to that. Sap, leaf tests, Albrecht tests. It'd be nice to know where I'm at, what nutrients I'm putting on that I don't need to put on, what nutrients I need to be putting more of. Less cultivations, more natural wormers for the cattle, and whenever grain grain's not really a lucrative market at the minute. We're not getting very much for it. Not that we're selling any, but if we can grow lucerne, is there a market that we're missing out on? It would be interesting to see if you put in a few more acres and sold it over Facebook Marketplace or something. Is there a market there that we could be moving towards? And yeah, thanks very much for listening. I'll take a few questions.
You mentioned the companion and intercropping. You fleshed out the companion cropping there a bit. Could you flesh out the intercropping a bit more? Ali, sorry, that's for Ali.
So our companion cropping, for companion crop at the minute, we're doing a lot of oilseed rape with beans, veg, buckwheat, sunflowers, clover, and yeah, we kill that out then. With our intercropping, we do maize. Intercrop, with spring beans and sunflowers that we take to harvest all together. I think they both work. They both have their places. I could probably companion a crop, as I mentioned, I didn't do it with barley and wheat yet. Probably over fear of herbicides, what herbicide I can use, but a research of probably let me know. I could probably play about with that a little bit and add a bit more companion crop into my wheat and barley as well.
Hiya. I was just wondering, we're just dairying at home, and I was just wondering, the silica that you're using, is there any benefit to using it on grassland? And are you buying, or do you have access to a mare's tail paddock for silica, or what's the story?
Well, we have, our roadsides is littered with mare's tail. So we have an abundance of it. I bought silica this year. Again, we didn't use growth regulator. I used a silica bought from Precision Nutrition. Very simple to use and quite cheap. I don't know if you would see a benefit to grass. It helps your cell walls, so you would probably see a plant health, yeah, but I don't know if you'll get any more yield or any more money for doing it, if you know what I mean. So I haven't tried it. Have you tried it?
Yeah, I'd agree with Ali. I haven't seen any. I can't comment on grass. I buy silica as well in a can. I don't go hunting mare's tail. I haven't time for that. Does it improve? So how I got to silica was a kind of an interesting story in itself. So we have a product that in conventional farming that we would have been using a conventional pesticide, Bravo or chlorothalonil as it's called, and it was removed from market maybe about 6 years ago. And it was a cheap enough fungicide to use, and it was giving good septoria control on winter wheats. But the powers that be and the good people decided in the EU that it should be removed from the list of products that we could use. So I looked for something to replace it with. And on a cost per acre basis, silica fitted that exactly. It was around €2 a hectare to use it at a litre rate, which is pretty much the rate I was using chlorothalonil on it. So I didn't see any negative effects. The spend was the same. And if you were to believe what you're told, it would be giving you some plant health benefits. So why not? That's my approach to this thing. Anything I do, it's a slow learning curve. You can't use something and suddenly proclaim that you're the next messiah or something. You have to measure it and then you have to repeat it. So for me, there's a repeatability thing in this year on year when I introduce something like silica and or Fermi juice or anything else. I want to see it working not just 1 year only, it has to run a couple of years. So it takes a long time to get results-based proof that any of this stuff works. But it doesn't not work. I can say that with 100% certainty. Yeah.
Thank you. Great presentations.
Hi, question for Tom. If I read your graph correctly, your reduction in pesticides relative to the average is 0 insecticides, big reduction in plant growth regulators, modest reduction in fungicides, and maybe a slightly higher use of herbicides. Is that a fair reflection? And can you describe how you plan to reduce fungicide use and how far you think you can go in that regard?
So fungicides are probably the easiest thing to reduce because you're applying them in terms of the crop, growing the crop, you're applying fungicides 3 times in a conventional system. So by replacing those fungicides with crop nutrition products and achieving the same result, I feel it's a win, you know. So so the reason that you hit on the PGRs, so I don't use PGRs anymore, which is a Psychocell product or a modem or any of those. And the reason I don't use them is because I want stem extension between the leaves on the plant. So when you're looking at a plant, it has leaves, in the trade they're called T1, T2, T3 leaves up along the plant like it's the head. and I want stem extension between those leaves so that disease gets a harder time trying to get up the plant, okay? Because that's what it's doing. It's getting in at the base of the plant septoria, and it climbs within 7 days to the top of the plant and annihilates the flag leaf, which is where your yield comes from. And so, yeah, I don't use PGRs for that reason. Stem extension is what I'm looking for. Yeah, you're running the risk of the crop lodging because you haven't put a PGR on it. But if silica does what it's supposed to do, it strengthens the cell walls and keeps the plant standing. So I haven't had a lodging crop, give or take, since I started this job. So, I mean, they're the wins. But it's hard to define them, and it's sometimes hard to quantify them and talk about them. But on the herbicides, it's probably I don't have more grass weeds than I did when I was in a plough till system, but I do have grass weeds. But then everyone has grass weeds, and so herbicides will need a controlled approach. But you can do a lot with crop rotation to eliminate a lot of the weeds that you like oilseed rape. If I grow oilseed rape, the herbicide I'll use will take out the grass weeds, which will give me a free year at least next year. I try not to use herbicides as much as like in conventional agriculture, you'll probably go with a herbicide post drilling, and you'll probably follow it up in springtime in March with another herbicide for weed control. I don't do the post drilling one; it's a complete waste of time and money. I just do one hit in March before the growing season starts, or just about, and that's it. Yeah, so I don't know if there's scope to reduce them any more than where they're at, but I'm all ears if someone mentions that there is something to help. Yeah.
Sorry, I might have missed it at the start, but just the lucerne, what way are you growing that or establishing it? And is it baled or pit? To presume you're feeding it to cows?
Yeah, so we grow it. We've grown it for 20-something years, 22 years, 23 years now. It's very similar to red clover. We grow it, establishment rates about like 10 kilos of lucerne, 2 kilos of red clover. We grow them together. We get about 3 cuts a year off it. It goes into the pit. It's controlled trafficking. So we've had many arguments with contractors and tractor drivers about where they should be driving, where they shouldn't be driving. Our headlands, well, it's a 40-acre field. It's in this year, and we have 7 or 8 acres of grass around the outside of it, so that the tractors, once they're off the lucerne, they go onto the grass. Grass grows back, lucerne doesn't. Yeah, we find a big benefit, especially because we're cutting silage 6 times a year. It's very soft and leafy of itself, so you need the lucerne to be able to stem here and promote some jag in the gut. But establishing it's very similar to just a normal field of grass or clover. You know, it's quite an expensive crop to grow. It needs a high pH, and it doesn't like compaction. So, I don't know if that answered or.
Yeah, thanks. Yeah.